In today's video, we're going to be taking a look at confidence intervals with the help of Python. We're going to go through a few different examples of calculating confidence interval as well as plotting them out with the help of libraries like NumPy, SciPy, as well as Matplotlib. And before we do jump into this Python code, I want to go over a lot more information about exactly what a confidence interval is and what information it gives us. All right, let's take a look at confidence intervals. So first, a confidence interval, which I'm going to abbreviate as CI, is a range of values derived from sample data that is likely contained through population parameter. The most commonly used confidence intervals that you'll see out there are with a mean or proportion. And often you'll see results as like, we are X% confident that the true value lies within this range. So 95% is going to be the most common confidence interval you'll see, but other pretty common ones are going to be 90% and 99%. So what 95% means, it covers 95% of the means. If we take 100 samples, about 95 intervals will contain the true parameter. The interval does not guarantee that the parameter lies within it. It reflects the probability of the method. Sample mean is going to be in the middle. So I have the equation down here to the bottom right, but I want to kind of explain how this works. So you have your sample mean, and then you're going to plus minus the standard error of the sample mean times the t-distribution of the 95% central region. Sounds confusing, I understand that, but we're going to go through a calculation. I think it's the next slide or the slide after, and it should clear it up. But first, let's talk about confidence versus probability. So confidence and probability are often used in casual conversations if they mean the same thing, but in statistics, they have different meanings. So when we say like we're 95% confident that the true parameter lies within the interval, it does not mean that there's a 95% probability that the specific interval calculated from our data contains the true parameter. Instead, it refers to the reliability of the method to construct the interval. 95% confidence interval means that if we repeat the experiment or sampling process many times, 95% of the intervals generated from those samples would contain the true population parameter. For a single interval, the parameter is either inside or outside it. There is no probability involved at that point. The true value is fixed. The interval is fixed once calculated. All right, so here is the example for running and calculating a confidence interval. So imagine we have a random sample of 25 marathoners and they're building up towards the marathon distance. So you find with these 25 marathoners that the sample mean is 20 miles and there is a standard deviation of 4 miles. So the first thing that we're going to do is we're going to calculate our standard error. So take 4 divided by the root of 25. You find that to be 0.8. Next, you find the z value for a 95% confidence interval, which is 1.96. So then you find your margin of error, which is going to be 1.96 times that standard error of 0.8, which is 1.568. Now, how we take this to finalize our confidence interval, we do 20, we add 1.568, and we take 20 minus 1.568. And the 95% confidence interval for the average marathon long run is between 18.43 miles and 21.57 miles. This means that we're 95% confident that the true average distance of marathon long run is between 18.43 and 21.57 miles. All right, so how we can influence the width of our confidence interval. You can see over here with our marathon one, right? It's not a super large interval, but here's a few things, right? Sample size. So larger samples is you're going to have a narrower interval. Variability. So higher variability, you're going to have a wider interval. And then the confidence level, right? Higher confidence level, 99%, you're going to have a wider interval. Where you go to 90% or lower, you're going to have a smaller interval. And you can see this graph over here that shows the width of the interval compared to the confidence level. Well, we'll actually be plotting this within the code in this video. One other thing I wanted to cover is multiple confidence interval. So a common rule of thumb is that if two confidence intervals do not overlap, it suggests that there's a statistically significant difference between the two groups of data sets. Non-overlapping confidence intervals dictate that the estimated ranges of plausible values for the two population parameters do not share any common values. Going back to the running example, right? I want to go over a runner that may run a 5-kilometer race. And when I'm going over these running examples, I'm just going to talk about hobby joggers. When you get to the pro side of things, it is completely different, right? So imagine someone going out to run a turkey trot 5K that isn't a serious runner, there's someone that just does it for fun, right? Their long run for that race might be anywhere from 2 to 6 miles. However, if you go onto the ultra side of things, ultra marathon is anything longer than a marathon. Let's look at a 50K race, right? You have about 31 miles. The long run on that side of things, the confidence interval might be 20 to 30 miles, right? 20 to 30 miles is a lot different than 2 to 6 miles. So because of that, right, these two are statistically significant. And because of that, we can say that these two groups are going to be different, right? And they are, right? You have something on the short side of things and you have something on the long side of things. And with that being said, I think we are ready to start coding in Python. So get your compiler ready and let's go through a bunch of different examples. All right, so let's start with our imports. Import numpy as np from scipy. Import stats, and then import matplotlib.pyplot as plt. I'll run these and then we'll get started. Awesome. So let's set up a random seed so that way you guys can duplicate the results that I have. So np.random and then over here .seed, and then I'm going to put it in here 20. And if you want the same exact results as I do, put 20. If you want to have different results, put a different number, but just remember that way you can repeat your results that you get. Awesome. So let me start with example number 1. So example 1, marathon long run. All right. And essentially what this is going to be, when you train up for a marathon, you're going to have essentially a long run right before the race. And that's going to be your longest run of the training block. So we're going to essentially create a confidence interval based around that. And yeah, a lot of running examples because I love running. So we're going to say data equals np.random.normal. Then we'll put our center on this side, about 20, which is pretty normal for marathon runners. We'll put a standard deviation of 4, right? And then we'll just say we took a sample size of 25, which is not a large sample size, but for what we're doing today, that's fine. And what I'll do next is we'll set up our mean. We'll say mean equals np.mean. We'll pass in our data over here. Awesome. And then let's also create our standard deviation. Before then, let me just print out this mean so you guys can see what this looks like. So print our mean, right? And our mean is 19.74. Now we're going to do a standard deviation. So std div like that, and then np.std. And what we're going to have to do also is do a DDOF. DDOF equals 1. Because we're doing a sample, right? And print that out also. So print out our standard deviation. And you can see 4.5. A little bit larger than 4. That's perfectly okay with me. Great. Awesome. Let's now find our length. So n equals length of our data that we just generated, right? And I shouldn't have to show you, but it's going to be 25. And there we go, 25. Awesome. Now what we want to do is find our standard error. So I've already covered this in another video, but regardless, standard error equals std deviation divided by np.square root of n. Like that. Awesome. We'll print that out also. And you can see 0.9107. Awesome. And then now let's look at our confidence intervals. So I want to find the confidence intervals for 90, 95, and then 99%. So what I'm going to do is I'm going to create a list over here. I'll say confidence intervals equal, and all I'm going to do is pass in 0.9, 0.95, 0.99. And what we'll have to do next is we'll create a for loop. And what we'll do is we'll pass through each of these confidence intervals. If I can spell it correctly, because I do a terrible job spelling on these live streams. well, not live streams, but when I do live coding. All right, so we're going to say for conf in, we'll have confidence intervals, right? First thing we're going to do is calculate our z value. So what we're going to do, grab our z value is stats.norm.ppf. Again, another video I already have on the channel, and we'll pass this in over here. So 1 minus conf over here divided by 2, right? That'll get our z values. Then we'll do our margin of error. So margin of error equals z times SE. And then we have to calculate both of our confidence intervals. So CI lower and CI upper. So it's going to be equal to mean. We'll do the lowest bound first. So we're going to subtract our margin of error. So mean minus margin of error. And then we'll do CI upper. And again, you don't need a for loop if you're just going to calculate one of these. But since I wanted to calculate 90, 95, and 99%, it made more sense just to have a for loop. That way we don't have to repeat a lot of the code. Okay, and then for our upper, again, we just add. So lower we subtract, upper we add, and then we can print this out. So print, and I'm actually just going to copy over what I have in my example code because I know I'm going to make an error. I make a lot of errors with f strings. So what I'm doing is an f string over here, right? Int, I'm doing the confidence interval that we get over here, right? Times 100. So 0.9 times 100, right? Which is 90. And then we add a percentage at the end. So I'll say 90%. Then we have our confidence interval, CI lower, right? Around it 2 decimal places, comma. Then I have our upper, again, around 2 decimal places. And I have these surrounded by parentheses. Feel free to print it out how you want. I just think the formatting looks a little bit better on that. And you can see our 90% is 18.27 to 21, 17.98 to 21.52. And then our 99% is 17.43 to 2207. Now let's think about if these results make sense, right? As we have a larger confidence interval, or percentage-wise, we should also have a larger confidence interval in here. Numbers-wise, right? 8279843, that's going down. 2352 and 07, right? With the 2 up there, that's increasing. So the length of this confidence interval is much larger than this 90% over here. So yeah, that makes sense. We have the correct answer on this side of things. So I'm gonna show you how we can influence the width. But again, just to reiterate what we did over here, right? We generated a normal distribution of marathon long runs. That's your training run before the marathon. We calculate the mean of that. We calculate the standard deviation of that. Then we calculate the standard error, right? Standard deviation but divided by NP square root, right? We found the confidence intervals for 90, 95, and 99%. We literally just went through the formula, right? And I showed you the formula already on the slides part of this video, but we just put that in a for loop so that way we repeat it, and then we print out that confidence interval. Awesome. Let's take a look at some plots. So we'll start with example 2. And I talked about 3 different things that influence the width of your confidence interval, but what I'm going to do right now is take a look at just the confidence level and then the width of the interval. So we'll say confidence interval width. And feel free to use the others if you want to, but I'm just going to do that for this video. All right, so what we'll do first is set up our confidence levels. So let's say confidence levels equals np dot line space, and we'll pass in 0.8, 0.99, and then 20 over here. And then we'll have our widths. And we're going to calculate all of our widths, so we'll have that as a blank list. All right, and now we're going to do another for loop, and essentially some of this code's going to be the same. So I'm just going to copy this, pass this here. So for confidence and confidence intervals, z equals stats norm, that's going to be the same. Margin of error is going to be the same. Now we're going to change these over here. So I'm going to say CI widths equals 2 times the margin of error. And that's going to be our total width, right? And what we're going to do next is we're going to append to this blank list. So dot append and CI widths. Awesome. And I have an error. Oh, because it's CI width in here. I'm like, why am I having the error? No, I still have the error. All right, I just reran these and it works now. So make sure this is width. We're passing in width to our widths over here. I messed that code up accidentally with the extra S. So only one with the extra S is our list above here. S right here, right? We're appending the width that we get each time we pass in that confidence interval. All right, so we have this now. And lastly, let's make a plot. So plt.figure, we'll have our fig size in here equals 8.6 like that. Plot, right? And then plt.plot. And we'll first pass in our confidence levels. So confidence levels time is 100. We'll pass in our widths. So CI widths. Then we'll set a marker. So marker equals O. And then color, set your color whatever you want. I'll just do purple. All right, so our title, plt.title. Confidence interval width versus confidence level. plt.xlabel. We'll have confidence level percentage. And then our Y label, we'll have width of confidence interval. Awesome. Let's show our grid. So plt.grid equals true. And we'll show it at the very end. Hopefully no bugs. Always have a bug. All right, so I was able to find the bug. I apologize for the errors so far in this video, but right here, I had confidence intervals. It should have been confidence levels, what I had right over here. So make sure you do make that change. And once that's changed, take a look. So you can see the confidence level over here. Like we have an 80%, right? Which means we're going to have a narrower confidence interval. But as we approach, right, you can see like 95, we have a little bit over 3.5, 97.5, right? We're over 4.0. And even over here to the right, when we get to about 99%, we're over 4.5. So I think this graph is awesome. It shows you the difference between our confidence level and then the width based around that. And again, I showed you the 3 different ways that we can influence our confidence interval width, but this is just the confidence level. But with that out of the way, I want to take a look at 2 different plots that are pretty common with confidence intervals. The first one is going to be a forest plot. Now the code is, it's a bit fun, but we'll do that. And then we'll take a look at a bar chart as well. But I think the forest plot is a little bit more popular. So we're going to do example 3, and we're going to look at a forest plot. So forest plot over here, and we're going to change up what we're taking a look at. So earlier we took a look at total miles for a training block. What we're going to look at now is we're going to take a look at marathon running times for a more of a serious runner, not necessarily someone that's elite, but someone that puts in effort, puts in like 50, 60 miles a week and is really training for a marathon. So let's do that. So I'm going to create 3 different groups of marathon runners. So we'll say data marathon group. We'll have group 1, and then we'll have 2 and 3. But a lot of the code's going to be the same. So to set up a random, so np.random.normal. Okay. And then we'll have our location, which is going to be our mean. The first group we'll say is 175. So again, that's just minutes, right? So That's going to be slightly under 3 hours, which is an awesome marathon time. So we'll have that. We'll have a standard deviation of 15, so scale 15. And then again, we'll just do our sizes of 25. And I'm going to repeat this 3 times. So 2 and 3, and we're going to change up a few of these things. So let's say group 2 over here is a 205, right? And we'll have our scale being 20, and then size 25. And then lastly, we'll have a 180, right? 3 hours on the dot, 10 and 25. All right, so each of these have a different standard deviation. Each of these have a different mean, and I think we should be good. So 1, 2, 3, perfect. And what we'll have to do is we'll have to label each of these over here in a list. So groups equals, and I'm just going to call them group 1, group 2, and group 3. And then what we'll also have to do in a second is have another list. We'll say data sets equals, and then we're going to pass in each of these over here. And tell you guys, my fastest marathon was about a 3:15, and I ran a 1:25 for the first half, trying to get a Boston qualifying time, and that did not work for the second half. But yeah, I didn't expect to do 1:25 for the first half. Now I do ultras, but regardless, let's calculate all these means. So we'll say means equal, and we'll pass in over here is np.mean, our data, right? And we're going to say for data in our data sets. Easy way to have our for loop like that. And our standard errors, we'll say equals, and inside over here, we'll say np.std. Again, pass in data, DDOF. A lot of this should be pretty familiar for you guys, right? And we'll divide this over here, not have a comma, by np.square root. That's in the length of our data. Although we could just say 25 because that's what we're doing. But for data in data sets. Great, awesome. And what we're going to do now is we already have our confidence levels right above over here. Where is that at? Well, actually, I'm going to change the code a little bit. It's in my example code. I had confidence levels. So conf levels and 09, 095, 099. Good with that. And let's say our colors. We'll say colors equal, and this is going to be the color associated with each of these confidence levels. So we'll have blue, we'll set up green, and then we'll also set up orange. So orange, that's, we have the 3, awesome. And now what we can do is we can start working on our plotting. All right, so now we're going to plot this out. So plt.figure, set our fig size. So fig size equals 4, and we're going to start off with a loop. So for I in conf in enumerate conf levels, again, some of this code is going to be the same. So first is going to be our z. So z equals stats.norm.ppf 1 minus, inside here, 1 minus conf divided by 2. It's our z value. Then ci intervals equals, set over here, list of comprehension. We'll have m minus z times our standard error, se. Then we'll have a comma. We'll say m plus z times se. And then say for m and se in zip, well, means errors. Okay, Then we have to set our lower and upper errors. So lower errors equals, inside over here, we'll have m minus ci0 for m ci in zip means confidence intervals. And I think this one's going to be, actually, sorry, should have ci1 minus m for m ci in zip means confidence intervals, and that's going to be upper. Awesome. Let's plot our error bars. So plt dot error bar, inside over here, x equals means, y equals groups, xerr equals lower errors, or upper errors, format that cap size equal to 5, color equals colors I, and then I'll just pass in this label. Just give you another f string. Just paste it over here. Label or f string int our decimal times 100, right? Add a percentage here for a confidence interval. I apologize if this slightly goes off the screen. And then what we'll do next is get outside of this for loop. Right. Hopefully this works pretty well. And we'll set our ax line. So plt.ax line. And this is going to be the average, essentially what we want to have. I'm going to say for a serious runner, our average is going to be, let's do my time, right? So I had about 195. We'll say line style equals color equals gray. And our label is going to be average marathon time for a serious runner. And then let's plot this out. So we'll have plt.xlabel. We'll have miles, or not miles, sorry, minutes. And then plt.title, forest plot with different confidence intervals. 90%, 95%, and 99%. That plt.legend, plt.gca.invert y-axis, plt.grid, and I apologize that there's so much code for this graph. Essentially, I wanted to show a forest plot with 90, 95, 99%. You can also just have it with one confidence interval, but I have all three of these here. I do have an error. Let's see why my error is. Oh, I had 3 dashes. Let's make that 2. There we go. Awesome. So forest plot with different confidence intervals, right? So what we have over here is we have the average in minutes, right? So let's say for a serious runner, the average is 195 minutes, right? And these are only 3 samples, right? I'm grabbing 25 runners at a time. That's very few in comparison to marathon runners out there, especially serious ones. Now, you can see over here, right? This confidence interval does have the average, right over here, but these other two do not. This is a lot smaller of a confidence interval, while this is much larger. And if we go to group 3, right, you can see our standard deviation is also a lot smaller, right? We have a 10 standard deviation compared to 15 or 20, right? We have our 20 over here, much larger than this one over here, which is just 15. And you can see, right, we have our 90, 95, and 99 all plotted together. So this is what a forest plot essentially shows us. We have our different groups, right? Group 1, group 2, group 3, where they lie in these minutes, and then the confidence intervals associated with them. I think it's a really awesome graph. But let me show you also another one that's pretty popular with confidence intervals. And this is just a bar chart. So this is going to be our last example. So example for bar chart. All right, so let's start plotting out this bar chart. So first thing we're going to do is plt.figure. And inside here, we'll set our fig size equal to 8 and 6. And then we'll set up our symmetric errors. So symmetric errors equals inside over here, low plus up, divide by 2 for low and up, in zip, lower errors, upper errors, and we already calculated those above, right? So makes this much easier. All right, next what we're gonna do is plt.bar of our different groups, right? Then we'll have our different means. And then inside over here, our y error, so y error equals our symmetric errors, which we calculate right over here. And then cap size equal to 5, color equals sky blue. Then we'll have our lines, so plt.ax h line, and this is going to be y equals 195. Again, what I considered my marathon time. So line style equals dash dash, color equals gray, label equals true mean 195 minutes. Okay, and then plt.y label mean estimate title for chart confidence interval, plt.legend, and plt.show, and hopefully no errors. Boom. We have our mean estimate, right, for each of these 3 different samples that we grabbed, those groups, confidence interval, and right, what the true mean is 195 minutes. So yeah, that was confidence intervals. Honestly, like, calculating the confidence interval isn't too hard, right? We saw this over here manually with this first example with the marathon long run. I used a normal distribution, find the mean, find the standard deviation, find the length of the sample, find the standard error, and then like just a few lines of code, right? Z, then you find your margin of error, and all you do is take your mean plus or minus that margin of error to find your confidence interval, depending if you want like 90, 95, 99. You can also change these out, but these are the 3 most popular ones. Really, once we started jumping into graphs, it got a little more complicated. This was just to show you guys essentially how the confidence level goes up, right? The width goes up as well, just proving what I showed in the slides. And then, yeah, forest plot is awesome, but it does take quite a bit of code to get that working. And then also this bar chart over here. Hope you guys enjoyed this video on confidence intervals. And if you learned something new, make sure to subscribe to the channel. One of our goals is to reach 100,000 subscribers in 2025. We're going to do that by uploading at least 3 to 4 videos every single week. Now, if you want to continue your education on statistics, I have a few videos linked down below in the description, as well as one right over here.